which is very acidic, to 14, which is very basic. The pH scale is rather similar to the temperature scale, assigning the values of hot and cold temperatures. The formula for pH of a solution equals to negative log of the hydronium ion concentration. So the definitions of pH or from observations, the concepts are that if you add an acid, the hydronium ion concentration increases and the OH concentration decreases. If you add a base, the OH concentration increases while the hydronium concentration decreases. When both are equal, then the solution is assumed to be neutral actually. The product of the two ions in solution equals to 1 times 10 to the power negative 14. So how do we measure pH? The pH of a solution can be measured if either the concentration of hydronium or hydroxide ion is known, or by using an indicator or a pH paper that develops a color which tells the relative pH of the solution. It can also be measured using the pH meter, which has a sensor that measures analytical property of a solution, and that is proportional to the pH. So how do we calculate pH? If you know the hydroxide ion concentration, or OH of a solution is known, how do you calculate pH? And if we know the pH, how do we calculate the hydroxide or hydronium ion concentration? We use these two formulas, this one and this one. If you are given the OH, you can calculate the hydronium, and if you are given the hydronium, you can calculate the pH. So whatever they give you, you can always find the hydronium to find the pH. For example, what's the molarity of a 1.0 times 10 to the power negative 4 molar hydrochloric acid solution? Well, we know hydrochloric acid is a strong base, so it dissociates completely. The hydronium ion concentration will equal to the molarity of the acid. So substituting the formula, you get 4.00. Now note the number of suffix here in the concentration there are 2, and here these ones are 3 suffix. The reason being that in pH, the digits before the decimal point don't count. So we have 2 here and here, these are 2. These are the ones that count. Okay, then how do we calculate the hydronium concentration from pH? If you are given, for example, pH 6, this one, using this formula, the hydronium concentration equals 10 to the power negative pH, which 10 to the power negative 6, which gives you this. How about the pH of a base? For example, if you are given a strong base potassium hydroxide of molarity, this number here, how do you find the pH? We know it completely dissociates in solution, so you know that the OH concentration will equal to the molarity given of the base. So find the hydronium ion concentration, from which you can find the pH of the solution. Here we go. This is the formula we use. The product equals this number. We know this, but we don't know this. Therefore, we substitute you get the hydronium concentration being 1 times 10 power negative 9, and then use pH equal negative log of hydronium and find the answer. Again, fix 2 here, and here this doesn't count, then 2. Then calculating OH from pH. For example, if you are given the pH is 4.95, again, you can find the hydronium concentration using the formula 10 power negative pH, which gives us that. Then use this equation to find the OH of the solution. Substitute and then solve. So basically this gives us common solutions that we use in our daily lives and their respective pH values. You can see among those, hydrochloric acid is the most acidic and sodium hydroxide is the most basic. So the idea here is that the higher the acidity, the lower the pH, as you can see here, and the more basic, the higher the pH, as you can see from this side. And the tenfold change in concentration changes the pH by 1 unit. Thank you for listening. Subscribe to my channel. God bless.